Now we're going to take a look at data transfer instructions. These are instructions that let us get data from memory to the register file and from the register file back to memory. So to look at these in detail, we need to extend the picture we had of the processor a little bit. We're not interested in the control part, so I've grayed that out here, but we are interested in how we get data from the register file to memory and back. The first step in this is to have the ALU generate an address. So in this case, if the ALU generates the address 24, we can do this by adding or loading from a register file. We then need to get this address to the memory so that we can access data 24 in the memory. So this address is going to go into a memory address register, and this register sits between the ALU and memory and allows the address to be stored there so that it can access the memory. When this address is in the memory address register, we can then use that to access the memory and get the data. When we get the data results from there, they need to be stored somewhere, and we're going to store them in the memory data register. So once we have the address, we can then use the address to get the data from the memory. This is now stored in the data register, and then finally we want to put this in the register file. So now that data is written back from the data register into the register file. And this is how we get data from the memory into the register file, and going the other direction is also very similar. Let's take a look at an example here. Here we're going to look at load word. So here's our program. Our program is going to do something. It's going to do an add immediate first. It's going to add 12 to R0 and store it in R5. That's going to be 12 plus 0, so it's going to put 12 in R5. And then it's going to do a load word. And it's going to load word into R6, that's the destination. And the source is going to be the address in R5, which is the result of the previous calculation. So let's walk through how this works. So our program counter starts at 0, which means we're going to load the instruction at address 0. We load that into the instruction register. The control logic is now going to decode that. It's going to figure out the ALU operation, which is add, and it's going to figure out where the inputs to the add come from. So one of them is going to be R0, and the other one is this constant 12. So it's going to add 0 and 12. It's going to take the result of that and store it into R5. And so now we've calculated 12 and put it into R5. Now the control is going to update the program counter, go on to the next instruction. And remember, each instruction is 4 bytes, or 1 word, so the next instruction is the current instruction plus 4. So now we go on to instruction number 4. Now we're going to execute instruction number 4, so our program counter points to memory address 4. We load memory address 4 into our instruction register. The instruction register is then decoded by the control, which tells the ALU what to do. In this case, the ALU is just going to pass the value through. The ALU is just going to take the address that it gets and send it on to the memory address register. It's also going to tell the register file what to do, and here we're going to read from register 5. So we're going to read register 5 through the ALU into the memory address, and now we have the address we want to access, 12. Now we're going to access the memory. The memory is going to read address 12, and it's going to put that back into the data register. Now we've read the value out of the memory, and now all we have left to do is to write it back into the register file, and we've loaded the value. So what we did here is we used an address from the register file to load data from the memory. That is, we had to have the memory address in the register file before we could access data from the memory. Let's take a look at another version. This is a load with an offset. So when you specify a load, you can put in an offset. That is, how many bytes before or after the location that you want to access. So look at what we've got here. Instead of having load word R6, R5, we now have load word R6 for R5. That 4 specifies that we're going to load something 4 bytes after the address in R5. Now when we execute this, we're going to load our instruction, the control is going to decode it, the ALU is now going to do an add instead of just passing the address through. The inputs to that add are going to be the address from R5 and the 4 from the instruction. We're going to add these together, we're going to calculate the new memory address, which is now 16, we're going to send that out to the memory, we're going to load that data from the memory back into the data register, and then we can store that data back into our register file. Offsets are very useful for programs where you have a bunch of different data types, particularly fields of data, that are close to the same base address. That way you can store the base address in the register file and access offsets to it very conveniently. Let's take a look at store. So stores are very similar to loads, but we need two things. We need the address from the ALU, just as we did before, and we need data. We need the data that we're going to store into memory. And this is why we have a memory address register and a data address register, so we can have these two pieces of data. So if we look at the store word instruction, we're going to load it into our instruction register. The control is then going to decide what to do. In this case, we're going to pass the data through, and it's going to tell the register file what data to pass through. So in this case, it's going to pass through the address, which in this case is 12. It's going to put that into the memory address, and it's also going to pass through the data, which in this case is register 6, and it's going to put that in the data register. Now both of these are then going to go to the memory, and we're going to end up writing the data into the correct location in memory. So again, store word is very similar to load word, but we need both the data and the address to do the write.